Hey there, in this video, let's have a look at some of the common symbols used for electrical components that are often seen in electric circuits. Here we have a basic setup of three components, namely a key, something to supply a potential difference across the circuit, in this case a DC cell or battery, and finally something that lights up, which is a bulb. So we may have to reproduce this type of a circuit very often on paper. Obviously, drawing these components as it is could end up becoming a difficult task. Hence, we use different symbolic representations for each of these in order to represent them on paper. Here is a list of electrical components and their associated symbols. It would be necessary to mention at this point that the list of components given in your textbook is exhaustive. That is, the number of components that you see over here do not make up all the available electric components that can be used in drawing circuits. Of course, the list of components shown over here are just enough for a student who's in the 10th grade. Now, the first one shows an electrical cell and the second one is that of a battery. We've already seen that battery is nothing but a combination of cells. So if we draw two lines, one longer than the longer one represents the positive terminal while the shorter one a negative terminal. If I take one cell and arrange them back to back, I get a battery. The next two, that is the third and the fourth component, is related to the plug key. Now there can be different types of keys. Over here they have outlined the plug key. What is a plug key? It's basically a key in which a plug can be placed. Depending on whether the plug is placed in the given position, the plug key can either be open or closed. Open meaning that the circuit is not complete, while closed means that the circuit is complete. Next, the fifth and the sixth one is related to how wires are drawn. Now, we can have wires crisscrossing each other. In some cases, they might be joined at a point or at a junction, while in the other case, the wires may not be joined but overlapping each other. So, depending on whether they are being joined at one junction or whether these wires are independent of each other but crisscrossing, can be represented by either of these two representations. The seventh one is that of an electric bulb. An electric bulb in a circuit is usually used to check whether the circuit is complete or not. This can be represented by these two loops, or if you are artistic enough, you can draw a bulb like this. But I think most of the books follow the first representation. Next comes the representation of a resistor. A resistor in a circuit is basically something that consumes energy. That is, it could also be called the load. Now, this is represented by these zigzag lines, or some textbooks usually depend on just drawing a small rectangle. So, if you see something like this in your book, this shows that it is a resistor. Alright. Next comes variable resistance. So this here is a fixed resistance, that is, the value of the resistance would not change. While in the case of a variable resistance, also known as a rheostat, we draw the same zigzag combination of lines with an arrow on top. The arrow meaning that this resistance can be changed. That is, it is variable. Another way of representing this is again with the zigzag lines, but now we draw a small arrow on top. Yes, so this arrow shows that if I move it to the left or to the right, the magnitude of the resistance could change. Finally comes are components, the ammeter and the voltmeter. We saw that the ammeter is an instrument that measures the magnitude of current, right? It measures the magnitude of current in a circuit, and it is always placed in series. While the voltmeter, on the other hand, measures the potential difference across 2 points. It measures the potential difference between or across 2 points in a circuit, right? So, how do you represent the ammeter and the voltmeter? The ammeter is represented with A written within a circle, while the voltmeter again with a circle and V written inside it. Do not forget to show the positive and negative terminals of the ammeter and the voltmeter. So these 11 electric components are necessary when we will be drawing electrical circuits. So keep in mind that you follow this particular notation in your book. This notation that I have shown for resistance is an alternative symbology that is lately being used in most textbooks. So this was about the different electric components and their symbolic representations.